Welcome to this video on Dev Basics with AI, where we will explore why AI agents forget context and introduce the Model Context Protocol, or MCP, as a solution. It's a frustrating experience. You give your AI agent detailed instructions and context, only for it to forget everything when you ask a follow-up question. This isn't poor prompting. It's an architectural limitation. This is known as the siloed genius problem. Modern large language models are highly capable, but isolated. They cannot automatically access your file system or remember previous sessions unless that context is present every time. The hard truth is that LLMs are stateless and have zero native memory. They do not remember anything between calls. Every response is generated solely from the tokens you send in the current request. Context is lost due to three main factors: token limits, which cause older information to be dropped; statelessness, meaning each request is independent; and the external world, as databases and APIs are invisible without a bridge. Chat interfaces create the illusion of memory by repeatedly injecting previous messages into the prompt. This causes long chats to degrade in quality, agents to contradict themselves, and doesn't scale effectively. Current approaches like vector databases and summarization are mere band-aids. These custom solutions create a scalability wall due to the fragile glue code required for every tool and model integration. This leads to an integration nightmare. Scaling 10 models with 100 tools results in 1,000 custom integrations. This is not an AI problem, it's an infrastructure problem. AI agents forget because context is fragmented, and tools lack a universal language for sharing state safely. This is where the Model Context Protocol, or MCP, steps in. Instead of trying to fix memory inside the LLM, we must fix how context is delivered to the model. MCP is a standardized bridge connecting AI, tools, and data into one cohesive ecosystem. MCP is an open protocol that standardizes how context is exposed, tools are invoked, and permissions are enforced. It provides AI with reliable access to context, moving beyond mere memory. Think of the USB-C analogy. Before USB-C, every device needed a unique charger. Before MCP, every AI model needed custom code for every tool. MCP is the USB-C for AI context. The MCP architecture consists of three core components: the host, which is the UI layer that manages safety; the client, which acts as the protocol bridge; and the server, which exposes specific tools and data. The host, such as an IDE, intentionally manages the conversation history and decides which context is sent. This moves memory control outside the model, allowing for full human oversight. Servers act as context specialists. They can safely read and analyze the local file system, connect to external applications like Slack or GitHub, and query databases without exposing the full schema. Resources provide read-only context, enabling the AI to read data using standard URIs. This offers standardized access, a predictable format, and a safe, read-only scope for data ingestion. Tools are defined actions with strict JSON schemas, eliminating the need to guess parameters. This standardized approach ensures safe execution and prevents the model from hallucinating function names. With MCP, prompts evolve from copy-paste instructions into reusable templates stored in the infrastructure. Remember, consistency beats cleverness in complex systems. This chart illustrates how MCP reduces "forgetting." Unlike legacy chat, where quality degrades over time, MCP ensures the right context is consistently reattached, providing long-term stability. Safety is maintained through a human-in-the-loop approach. Dangerous actions require explicit human confirmation, ensuring agents operate under a strict consent model defined by the MCP host. MCP also leads to optimized performance and token efficiency. By processing data near the source and only sending essential summaries or logs, we achieve higher reliability and lower latency. The robust security model relies on isolated servers with no hidden access, the principle of least privilege, and explicit consent to prevent any silent escalation of privileges. In summary, the Model Context Protocol changes the fundamental mental model of how AI agents interact with the world. Use MCP when building AI agents, complex workflows, or multi-tool ecosystems. You can skip it for simple chatbots, static FAQ bots, or single prompt tasks. Ultimately, the key takeaway is that context is greater than memory. MCP doesn't make the AI inherently smarter, but it makes your AI systems reliable and scalable. Thank you for watching this video. Please stay updated on the latest developments.